Well, hello everybody, and seasonal greetings to you all for the December 2021 Virtual Planetarium with Pete Lawrence and myself. And we're going to start, as we usually do, with the inner solar system and the innermost planet, the planet Mercury, which is sort of visible towards the end of the month, 30 minutes after sunset, but not terribly good. It's poorly placed for much of December, isn't it?
Yes, it is. It is. It's as you say, it'll improve towards the end of the month, and it'll be helped by Venus, which will mark the way to it. On the 19th of December, Mercury sets around 35 minutes after the sun, and despite shining at mag minus zero point 0.7 on that date, it will be tricky to see because of its position.
Yes, terribly low down. And that's been the case for Venus, second planet out. Although Venus has been visible in the evening skies, it's been so low down. And I normally observe Venus during the day, but I found even in the daytime, the planet was still too low down. So I haven't actually been able to do much Venus observing at all.
No, which is a bit of a problem. I've only seen it a few times. It's a combination of low altitude and poor weather, actually, which is...
And you've got a splendid western horizon, so if you haven't seen it, I've got no chance.
No, okay. Well, what about Mars then?
Okay, so Mars, as we know, is now appearing in the morning sky. It's slowly returning. It takes a while to get into a good position, and it's quite small in the eyepiece. It only has an apparent diameter of about 4 arcseconds across, so not great. But if you've got a large telescope and an imaging setup, you might well be able to capture some details because the technology now allows that to be the case. So
yes, it does.
It's not a complete write-off, but it's going to take some time before it becomes good again.
It's also worth mentioning that there's a 1% lit waning crescent moon 4.5 degrees east-southeast of Mars on the morning of the 3rd of December. And on the 26th of December, Mars appears 4.6 degrees north of magnitude plus 1.0 Antares, which is its rival in the sky, isn't it?
It is, although not really a rival, is it, in colour or intensity? When Mars is close to opposition, I always think that Mars looks much more orange and salmon-coloured than Antares does.
That's an unfair comparison, though. When Mars is fainter, it does look like Antares.
Well, it looks like a small red speck when it's faint. There's lots of stars and planets that would look like that. Anyway,
okay.
We won't be getting Mars good really till towards the end of the year, but
the end of next year.
Yes, at the end of next year. Jupiter's still hanging about, though. Magnitude minus 2.3. It's 23 degrees up in the sky at the start of December, under deep twilight conditions, so not completely dark. But by the end of December, the sun's still up as Jupiter reaches this position, and it starts to set, sort of 4.5 hours after that. So probably had the best of Jupiter for now. But next year, 2022, the planet, when it returns after solar conjunction, will be even higher in the sky than it has been this year, which I'm sure will be a great relief to a lot of UK-based astronomers.
Oh, it'll be heaven, won't it? Absolutely heaven. There's a waxing crescent moon nearby to Jupiter on the evenings of the 8th of December as a 25% lit waxing crescent, and on the 9th of December as a 35% lit waxing crescent. And at the start of December, Jupiter lies within the border of Capricornus, but mid-month crosses into Aquarius, where it will remain for the rest of December.
That's quite good. Quite well placed. Next planet out, Saturn. Oh dear, still quite low. I've been saying this for years.
I know.
But at the start of December, it's magnitude 0.7. No longer appears above the southern horizon in darkness. It's only visible west of south as the evening twilight deepens. And at the start of December, Saturn lies in the middle of a line formed by Jupiter to the east and Venus to the west. Rings are still quite wide open, but it is quite low down, so poor seeing conditions will probably affect the planet.
Okay, well, let's go out to the evening planet Uranus, which is also the best placed planet for the UK at the moment.
It has, and for a number of years on and off, Uranus has really been the best placed planet out of all of them.
Yeah.
In the evening sky. It was at opposition last month, so it's going to be well placed throughout all of December and reaches a staggering altitude of 52 degrees in darkness all month.
Yeah.
It's magnitude 5.7, so technically naked eye visibility, although that's probably quite difficult. And it sits 25 arc minutes southeast of the magnitude 6 star 29 Ariatis on the 29th of December.
Which is pretty good, actually, because they're quite close in brightness, so that creates a nice, easy pair to see.
And Uranus's colour, I find, is quite distinctive in the telescope. It's sort of greenish cyan coloured. It's really quite noticeable. If you've got a large telescope, it's well worth imaging because the planet has shown some storms and variations over the past. And you might be able to catch also some of the satellites, which can be quite tricky visually, even in a large telescope, but obviously don't pose nearly as much difficulty for an imaging setup.
No, it's worth noting as well that, I mean, the big problem with Uranus at the moment is the fact that it's in a part of the sky which is quite difficult to navigate because there aren't really many bright stars around there. So the trick is to locate Hamal, which is Alpha Arietis, and then Menkar, which is Alpha Ceti, and then draw a line between them, and the midpoint sort of marks the region where Uranus is.
Yeah, and I find that in my 10 by 50 finder that Uranus does look different from the rest of the stars in the field. There is something non-stellar about it, even in a very small instrument. So, the colour is, I think, just about perceptible in a fine scope. So it shouldn't be too difficult to track it down.
No. Okay. Well, Neptune is still in a reasonably good position, but its status is declining this month. As it drifts ever further to the west, then it's going to lose altitude as darkness falls. Its magnitude plus 7.9, and it only reaches its highest altitude of 32 degrees in total darkness until mid-month, really. And then at the end of the year, it starts to get lower and lower to the west of south as true darkness really falls. Okay, so let's have a look at some of the specials which are going to be occurring in December. And there are a few of interest. We've already mentioned that around the 8th and the 9th, you've got that beautiful crescent moon very close to the bright planet Jupiter, and that will stand out pretty well because it's a good time of evening for people to go out and see it, and Jupiter is particularly bright. And if you have a telescope and you look at the moon on the night of the 12th of December, have a look at that large crater Clavius, which is in the southern part of the moon's disk. And that's where you might see this clear obscure effect known as the eyes of Clavius, when the inner craterlet rims are illuminated early on.
Yeah, that's quite a distinctive effect, actually. Although I've never seen it live in the telescope, I've seen images of it, and it really does look like eyes emerging in the darkness.
Yes, it does. It does.
Okay, well, on the 13th, night of the 13th, of course, we have the annual Geminid meteor shower. This reaches peak activity of around 0700 UT on the 14th of December, making the 13th and the 14th ideal to look out for Geminid meteors. Now, there is a 78% lit waxing gibbous moon that sets around 0300 UT on December of the 14th. So that leaves about 3 hours of dark sky after that. So that would probably be the best time to observe the Geminids.
That's great, actually, because that's the run up to maximum. So that should be pretty good. And the altitude of the radiant will be getting really high at that time. So ideal.
Yes, but don't forget to wrap up warm because it will no doubt be very, very cold.
Yeah, okay. Well, on the 21st of December at 15:59 UT, the centre of the sun's disk reaches its lowest position in the sky relative to the stars, its most southerly position. And that's an instant in time called a solstice. And for the northern hemisphere, this is the winter solstice. And for those in the southern hemisphere, of course, it's their summer solstice. The sun is highest for them at this particular time.
And on the 22nd, this is a nice event. If you take a telescope and look at the planet Jupiter, as the sky will be getting dark, you'll see the shadow of the largest moon, Ganymede, crossing the planet's disk. This event ends actually at 1845 UT, but the shadow of Ganymede is actually quite large and very dark, and
Yes,
I've seen
it
it in a 3-inch telescope, so it can be a very prominent thing to catch. So all you really need is a clear sky and a reasonable telescope. It doesn't have to be particularly large to see that.
No, that's good. Okay, on the 24th, in the morning sky, there is a 78% lit waning gibbous moon, and as it passes its highest point due south, it will be occulting the star Eta Leonis. And from the centre of the UK, the star will disappear at 0416 UT and reappear from behind the moon's dark limb at about 0509 UT. Now, if you live in different areas of the UK away from the centre, those timings will be slightly different. So give yourself about 10 minutes either side to make sure you see them.
On the 28th, magnitude minus 0.7 Mercury and minus 4.3 Venus appear quite close. We will need a flat southwestern horizon to see this, and this event occurs approximately 40 minutes after sunset. In order from the Sun, it's currently possible to see Mercury, Venus, Saturn, Jupiter, Neptune, and Uranus in the evening sky, although Uranus and Neptune require binoculars. So it's entirely possible then to get a great swath of the entire solar system in an hour's viewing, which is quite something.
It is quite something. Don't forget, you can also see the Earth, which is your horizon.
Well, one could say you would see the Earth anyway because you're looking through the Earth's atmosphere to see the planets. So you're automatically looking at the Earth.
Oh, you're such a pedant. But the one which is missing, of course, is the planet Mars, which is in the morning sky. And Mars, on the 31st of December, will remain very near to its celestial rival, even though Paul doesn't think it looks like its celestial rival, Antares. And the name literally means the rival of Mars, proving just how wrong Paul is there.
This doesn't prove anything of the sort. It's just a name. And you saying the name louder doesn't make it any more true.
We'll give that a go. Okay.
All right, the stars. Moving out to the stars, where, of course, this time of year we are very, very lucky. We have some really splendid, magnificent constellations. Autumn is now fading into the west, with Pegasus heading down towards the western horizon. And to the east, the eager stars of spring are patiently waiting their turn. We have the constellation of Leo the Lion, gaining altitude in the early hours. But being December, though, the southern part of the sky is dominated by the main constellations of winter, and obviously first place of that goes to Orion the Hunter.
Fantastic, isn't it? You've got 7 bright stars there making up the familiar shape of his upper torso, the belt, and his legs, or I think his knees, aren't they? Some of those at the bottom.
One of them I think is his knee, yeah. I think the other one is his foot.
Yeah. So you got the bright orange star in the upper left of the main group of the 7 is Betelgeuse. And Betelgeuse is still here, despite all the predictions which said it was going to explode.
Yes, there did seem to be a lot of fuss about this. I thought I was quite surprised to have the fuss about this, Pete, because Betelgeuse, as we know, a little while ago underwent quite a dimming. It got quite faint. But supernovae, they kind of do the opposite of that. They get really bright and they fade down. I think recent observations of it have shown that it was. I think we suggested this, didn't we, Pete, in one of the Virtual Planetariums? Because Betelgeuse is like a carbon star, it produces a lot of soot, and that can block out the light from the star between us and the star. So that's why it appears to dim. I think there is a lot of cloudy material around Betelgeuse which is responsible for the dimming.
Yeah, absolutely. Well, okay, extending up from Betelgeuse is Orion's Club, and it almost appears as if the Hunter is about to give Castor, which is one of the twins of Gemini, a surprise by smashing him on the foot. That's how it looks like it's depicted in the sky anyway.
Yeah.
Now, his other shoulder is marked by the fainter star, Bellatrix, or fainter than Betelgeuse at least. It's still a very bright star. And there is, beyond that, above Orion and to the west, so to the northwest of Bellatrix, there is a region of sky which has a lot of faint stars in a like a sort of arc. And those are the pies of Orion, because where you have the Bayer letters, the Greek letters, sometimes when they're catalogued, they have numbers against them. So you'll have pi 1, pi 2, etc. And I think in this case it goes up to pi 6, if I remember.
I think so, yeah. So, and those are, well, I've only ever heard you call them the pies of Orion, but it's a perfectly reasonable name because that's what they are. It's interesting, isn't it? Because you can actually test how dark your sky is by seeing how many of them you can see.
Yeah, that's a good way of doing it. It's an interesting region though, because I think in depictions it shows the skin of a lion. These whole
it's a crumpled up lion that Orion has hunted.
I like that, just
killed.
a crumpled up lion. Yeah, I like that. But it looks, when you actually look at a chart, more like a bow. That's the shape it sort of depicts, as in a bow and arrow.
Yeah, and that would probably make more sense, wouldn't it, given that he's a hunter, he's holding something that he's going to hunt with, but...
No, crumpled up lion it is.
Crumpled up lion it is. These stars, together with Omicron 1 and Omicron 2 Orionis, these form a shape, as you've just said, Pete, that are very reminiscent of an archer's bow, aimed at Taurus the bull. And that's a nice constellation which contains a number of interesting objects. Let's go back to the centre of Orion, and we have the three belt stars, which are quite distinctive, and they are Mintarka, Alnilam, and Alnitarch. Is that right, Pete?
That's right. Yeah, that's absolutely correct.
Unmistakable. They form this almost straight line in the entire sky. And, of course, below these, we have the very famous nebula M42, this fuzzy patch, the Orion Nebula, which is a vast star-forming region. New stars are being formed there right at this moment. I think it's one of the very few nebulae that's actually visible to the naked eye.
Well, you say that, you see. I've never been wholly convinced you can see it with the naked eye, because that region is the sword of Orion, of course, which is full of other deep sky objects. You've got a couple of nice clusters. There's lots of other nebulosity, but there's also some faint stars there. So you sort of see it, and you get all excited about it because it looks like something interesting in the sky. But just next time you're outside, look at it and see if you can actually make out the nebulosity with your naked eye. I'm not sure you can.
I see. I'm not sure it's necessarily nebulosity that you have when people say you can see the nebula. It looks like a fuzzy patch to the naked eye.
Yeah, but that's because it's got a lot of faint stars there.
That's just details. The point is, it looks fuzzy. It doesn't look like a stellar object. Stop being pedantic, Pete. It obviously looks non-stellar, and you can tell it's an interesting region with the naked eye. You're right, I'm not sure you could tell about the nebulosity, but it does look fuzzy and slightly indistinct, and I think that's what really gives it away.
It's interesting as well, you're talking about the three belt stars, Mintarka, Alnilam and Alnitarch. They form this straight line, and they're roughly similar in brightness, and they're equidistant. So basically, the middle one, Alnilam, is in the middle of the other two. But it is really distinctive, isn't it? You can see that without seeing anything else. If it's cloudy and there's a gap where those three stars are visible, you know instantly what it is.
That is true.
And I find that rather amazing.
It is very true. The region also contains M43. This is another patch of nebulosity near to M42, as well as a number of clusters. In fact, there's a lovely bright group of 4 stars near the very heart of M42. This is the trapezium cluster, a very small open cluster that has recently been born. You can see those stars have recently been born in that nebula, and many billions of years ago, our own sun would have formed in a similar nebula. Maybe somebody else all that time ago, Pete, was doing a virtual planetarium looking at our star forming in the heart of some giant nebula.
I doubt it. Anyway, below Orion, there's the most tortured constellation in the entire night sky, which is, we often mention this one, which is Lepus the Hare, which is Orion's prey.
Yeah.
So you've got Orion, you've got Canis Major, his dog, his great dog, and Canis Minor, his little dog, and they're all converging on Lepus. Which is a bit unfair.
You say it's a little dog. Are you sure it's not the same size dog, but just further away? You see?
No, it's definitely smaller. And, of course, Canis Major is made up of quite a few stars, including Sirius, the brightest star in the night sky. And it looks like a dog running up the sky towards its master Orion, whereas Canis Minor is made up of 2 stars in a line.
Could be
How
anything.
does that work? Yeah, it could be anything. Canis Minor, the grasshopper.
Yeah, it could be anything with just two stars. Should point out, actually, that several objects of note in Lepus there, including the magnitude 8.5 globular cluster M79, that's towards the southern border of the constellation, and towards the rest we have the red star R Leporis. This is another carbon star, and it slowly varies its in magnitude over time.
It does.
That globular cluster M79 is quite low down, and in fact, I've only ever seen it once personally.
It is a tricky one because of its low altitude from the UK. Arla Porus is rather lovely. That's Heinz Crimson Star.
Yeah, it's a beauty.
He described it as looking like a drop of blood against the darkness of the night sky, which is quite fitting but it looks really intensely red when it's quite dim, doesn't it?
Yeah, it's actually a very interesting phenomenon. I follow a number of variable stars, and these red carbon stars, they only hit that kind of intensity red and are that prominent when they're about magnitude 9, between magnitude 8 and 9.
Okay.
Before that, they look quite bright and orange, and after that, they're quite dim, and it's, again, slightly harder to tell the colour. And during that time when they are their prominent red colour, that's when it's hardest to make the observations because they're so obvious in the eyepiece that you get a natural bias towards to making the observations, so you have to be a bit more careful when those carbon stars are in that phase.
Okay, interesting information there. Okay, with that, we'll end.
You could sound a little more convinced.
No, I am. I'm genuinely. I find red stars to be fascinating to look at anyway. There are a number of them up there in the night sky, and it's well worth looking them up, actually. There are lots of lists on Google, etc., where you can find these red stars and just comparing them. And they're quite compulsive once you get going with them, aren't they?
They are. And as you said, there's a list you can find with a good number of these on, many of which are actually visible in the winter night sky at the moment. So good time to look. I guess we should wish all our listeners a happy Christmas and happy New Year and clear skies for 2022.
Absolutely. Looking forward to that. Okay. Thank you very much, Paul.
Thanks, Pete.